Good afternoon. This is the unit test on functions. Number 1, select the equations below that represent linear functions. So linear, you're looking for lines that are like y equals mx plus b. They might also look like 3x plus 5y equals 10 because you could just solve that equation for y by subtracting 3x to both sides. And you could get it to y equals mx plus b. So let's look to see which ones look like y equals mx plus b. A, not, because of absolute value bars. Exponent, nope. Exponent, nope. This D is a line, because it can be rewritten to y equals mx plus b. Absolute value bars, not a line. Y equals mx plus b. F is a line. Y equals 4. That's a horizontal line. And y equals x. That is also a line. Number 2. Given the function below, evaluate f of negative 2. That's how you would say that, f of negative 2, which means x equals negative 2. So, x, I go to the x-axis, find negative 2, there it is, and the function point that we're talking about is right here. That is the point negative 2, 1. So when x is negative 2, your y value is 1. So we're looking for C. On 3, given this function equation, now we're trying to evaluate g of negative 1. That means x is negative 1. So we're going to put negative 1 right in for x. Negative 9 times negative 1, add 2. Negative 9 times negative 1 is 9, plus 2 is 11. 11 is your answer. Domain and range. Domain is your x's. Range is your y's. We have a segment here. So for the x's, I'm going to look from the left side to the right side because my x-axis goes left to right. My leftmost x is negative 5. My rightmost x is 4. So I have x values in between negative 5 and 4. Because this one is an open circle, I'm going to leave that less than. This is closed, so I'm going to have an equal to underneath. The range. The range is your y's. The y-axis goes up and down. So we look low to high. The lowest y value is right here at negative 2. And then it goes up to the highest y value of positive 3. So I have negative 2 is less than y, which is less than 3. Because it's an open circle on this one, at the negative 2, I leave that open. Because it's closed on the 3, I'm doing an equal to on the 3. Number 5, graph the linear function. This is in y equals mx plus b. The m is the number in front of x. I have nx or 1x. So my slope is 1 or 1 over 1, a positive slope. My b is a 2. That means I'm starting the graph at 0, 2, up 1 over 1. Number 6, describe the transformations. There was an error on this over here, but I'll get to that in a second. Here's your A. A is negative 1/3. Your H and K. Negative 5, negative 1 is your vertex. Because the A is a negative, you should select reflection. Because the A is a fraction, that's when it's going to shrink because it'll be a much wider V-shaped graph. So that's a vertical shrink. -5, -1. Think about how you would go plot that on a graph. To plot that, I would go left 5, down 1. Let's see, left 5, check, down 1. So this one had a mistake. So some of you did this when you did it, which was great. Down 1. Number 7, graph the absolute value function. You want to identify your A, H, and K. The A is a 2. That means you're going to go up 2 over 1. H is the opposite of the H, so that's a 1. Oh my goodness. And K is a -6. Your HK right here, these two, become your vertex point. So you're going to plot that first. 1, 2, 3, 4, 5, 6. 1, -6 is your vertex. From that, I'm going to create a V because this is an absolute value function. That makes a V, not a line. I'm going to go up 2 over 1, up 2 over 1 to both sides. And that looks good enough. Oops. Arrows, because it can keep on going. And that's what that graph should have looked like. Piecewise function. This is the line, y equals -3 over 2x minus 5. You graph the line lightly. So let's start there. 1, 2, 3, 4, 5. Up 3, 1, 2, 3, over 2. 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 Can't go any further. So we're talking about this line here. Now we don't want the whole line because we have this, which is technically your domain, or the piece of the line that you want. We want to keep when x's are between -6 and 2. 1, 2, 3, 4, 5, 6. So this is -6, 1, 2. This is +2. I want to keep where the line is between that space. That's it. So everything behind my hands I need to erase. So I'm going to keep here to here. Keep all this. And I erase the other sides. I only want a piece of the line. They're both filled in circles because of these two symbols. Last one, another piecewise, which is a more typical one. The first one, this is the line y equals -6. 1, 2, 3, 4, 5, 6. That's this line right here. But we don't want the whole line. We want when x's are less than 0. So that's here. This is when x is 0. Now think about less than 0. Is that this side or to the left? The numbers to the left of 0 are the numbers that are less than 0. So I erase this side. I only want to keep that left side of the line. Then the second line, y equals 3x plus 2. Lightly go graph that. Start at 2, 1, 2, 3, over 1. 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 So that's the whole line. And now this says x's, right here, are greater than or equal to 0. So that's here. That'll be a filled in circle because of that equal to sign. And the numbers greater than 0 are to the right, like 1, 2, 3, 4, 5, 6, 7. So we keep this side and we erase the other side. And then this as a whole is your answer. And I think that was it. Yep.